Good morning, everyone. I take this privilege to introduce our next keynote speaker, Dr. Praveen Kolli garu. Dr. Praveen Kolli is a senior machine learning engineer working in the ads ranking team at Pinterest. At his current position, he builds deep learning models for predicting engagement rates between user and ad pairs. Before that, he worked at a startup called Huzo Inc., where he built bidding algorithms for 10 million plus products that house advertisers on exchanges such as Google and Microsoft Bing. Prior to that, he obtained his PhD in mathematics from CMU, Masters in Mathematics of Finance from Columbia University, and Bachelor's in Electrical Engineering from India, IIT Kharagpur. Today, Sir will be addressing on the topic machine learning in ads, and he will address some of the challenges that arise due to petabyte scale data and how machine learning is used to tackle these challenges. We welcome you, sir.
Thank you for the invitation. Thanks for the introduction. Can you guys hear me?
Yeah, we can hear you, sir.
Okay. Yeah, I want to thank the organizers for inviting me for this conference. Uh, my name is Praveen Kolli, and today I'm going to be talking about how machine learning is used in the context of ads. Okay, this is the brief agenda that I have for today's talk. I'm going to talk about, I'm going to give a brief introduction to the ads, and then I'm going to talk about ads marketplace, and then I'll talk about the ad system itself. I'll give an overview of the ad system, and then I'm going to talk about how machine learning is used to predict click-through rates. And then finally, I'm going to conclude by talking about a few interesting problems that exist in this space. Feel free to interrupt if you have any questions. Okay, with that said, I'm going to give a brief introduction of the ads domain. So this is a screenshot from my Facebook feed. So if you look at the red bounding boxes, so there is a red bounding box with sponsored, where you see sponsored content. So these are ads. And then there is another ad that you see pertaining to mortgage rates. At some point, I was looking at interest rates on Google, and then I got targeted by this lender called Lengo on Facebook. So these are some examples of ads. Okay, what are the other types of ads? Let's say you go to google.com and then you search for dining chairs. You see a lot of picture ads at the top. These picture ads that you see at the top are called as product listing ads. And then there's another ad below from wayfair.com. This is called as an SEM ad. SEM stands for search engine marketing. So these are two types of popular ads, product listing ads and SEM ads. Okay, so what do we want here? What do advertisers want? Advertisers, let's say I'm selling shoes. I want to target users, end users who are interested in buying shoes. In other words, I want to target uh, audience who are interested in buying my product. So that's what advertisers care about. They want to reach out to as many users that are interested in buying their product. So social media companies benefit greatly by showing relevant ads to users. And advertisers pay social media companies on a per click basis or on a per impression basis. The ad revenue itself in US in 2018 was more than $100 billion. This number went up significantly during the pandemic. Okay, so ads marketplace. Ads marketplace comprises of three players. You have users, you have social media platforms such as Google, Facebook, Pinterest, Twitter, Snap, and then you have advertisers. So users, you know, they they use a lot of these platforms. So they have these apps or they visit these websites. Let's say a user visits facebook.com and then the user goes to social media platforms such as Facebook. wherein advertisers advertise, let's say, a product that they want to advertise. Users who are browsing on this platform, they click on ads and then they go to the advertiser's webpage. So to summarize, social media companies have a supply of users' attention, and advertisers are paying for this users' attention. This creates a marketplace. So this is an overview of the ad system from the social media company's perspective. So the objective of social media company, of any social media company, is to show relevant ads to the users that are coming to its platform. The reason why relevant is important is because, let's say I'm facebook.com and I'm showing you irrelevant ads. If I'm showing irrelevant ads, then you're not going to engage with the platform, and you'll stop engaging with the content that I'm showing to you. You will lose interest on the platform, and then you will leave the platform. If a lot of if a particular platform has a lot of churn, meaning if a lot of users are not engaging with the content that is shown on the platform, which essentially means advertisers will stop advertising their products on the platform, which inherently means Facebook is going to make less money. So on the other hand, if Facebook is showing relevant content to the users, it means users are engaging with the content that is surfaced to them. It means they're going to be clicking on a lot of content. They're going to be clicking on ads. And then when they click on ads, they go to the advertiser's web page, and then eventually they'll make purchases on advertisers' websites, which means advertisers are happy. They're making money out of it. Users are happy because users are engaging with content that was shown to them on facebook.com. Facebook is happy because advertisers are paying them uh, whenever a user sees an ad or whenever a user clicks on an ad. So it's a win-win for everyone if the social media company is showing relevant content to the users. Advertisers are happy because they're generating revenue whenever a user makes a conversion. Users are happy because they're engaging with the content that is shown to them, and Facebook is also happy because they're making money by showing ads. So this is the overview of the ad system. A user, let's say, types in a query on google.com, or let's say a user goes to any social media website. You have a query in the context of Google. You can think of this as a search query, or you simply have the context as in from what part of the world the user is signing from, or what was the time of the day when the user logged in, or what device is the user logging in from. Is the user logging in from an Apple iOS device or an Android device, or is it a desktop, or is it a MacBook? So this is all encapsulated in the context. So once all of this information is collected, there is a candidate generation that happens, which is followed by a lightweight scoring. It's when I say lightweight scoring, it's a machine learning model that is not overly complex, that does the first round of scoring. And after the first round of lightweight scoring, the candidates are then ranked or are scored by another heavyweight machine learning model. And the top candidates from the ranking layer, the candidates from the ranking layer are then fed to the auction. And the top candidates from the auction, essentially the auction winners, let's say top X candidates. We'll talk about what's going on in each of these layers in the subsequent slides. Uh, so going back to auction, so there is the output from the ranking layer. After the ranking layer, there is an auction, and after the auction, the winners in the auction they get shown to the user who's browsing the social media website. And then whenever the user sees an ad, he or she can either interact with the ad When I say interact, the user can click on the ad or the user can ignore the ad. So this goes into this data goes into training the models uh, in the heavyweight ranking layer stage as well as in the lightweight scoring stage. So this is the brief overview of the ad system that is employed by the social media companies. Okay, so what is the scale? The scale, there are roughly 100 million to a billion users, and then we have 100 million ads roughly. Now, for every user that comes to, let's say, Pinterest.com or Facebook.com, we want to score. What we want to do is we want to predict the probability that this user will click each of these ads. But let's say you have 100 million ads. For every user, we want to predict what is the probability that the user would click ad A, ad B, so on up till ad at the 100th million position. So in principle, we want to do that. But if you want to predict probability of click for each user for each of these 100 million ads, it's quite expensive. The latency is going to be very high. What I mean by latency is, let's say, whenever you go to facebook.com, it takes, roughly 400 milliseconds for the page to load. Now, if you have a machine learning model that is predicting probability of click for each of these 100 million ads, it's going to take several seconds for the page to load. It leads to a bad user experience. So you want the page to load with organic content as well as ad content within 400 milliseconds. So what this essentially means is you can't predict probability of click for each of these 100 million ads. So what we do is, so if you go back to the previous slide, so there is the candidate generation layer followed by a lightweight scoring and then in the candidate generation layer, we trim the ads, we filter the ads, we reduce from 100 million ads, we reduce it to, let's say, 100,000 ads. And we do lightweight scoring on these 100,000 ads. And then we pick, let's say, a top 1,000 ads that are sent to the ranking layer, wherein we use a heavyweight machine learning model to predict probability of click for these 1,000 ads instead of predicting probability of click for 100 million ads. Okay, so yeah, candidate generation. So in candidate generation, we trim ads to roughly 1,000 ads for each user. And then what do we do? What exactly happens in candidate generation? Advertisers specify targeting attributes. So advertisers say, hey, I want to target users who are staying in Bombay or Hyderabad or Bangalore, who are in the age group 25 to 35, and who are searching for, let's say, dining chairs. So this is one targeting attribute, or you can have other targeting attributes like, oh, I'm going to target users who are signing in from Apple devices, or I could say I want to target uh, users who are interested in fashion, or I could say I want to target users who are interested in electronics. So advertisers specify these targeting attributes. And when, let's say I'm a user, I go to facebook.com. Now, Facebook has a repository of 100 million ads. And based on these targeting attributes from the total repository of 100 million ads, after the candidate generation filters are applied, roughly 100,000 potential ads are filtered out. So now when I go to facebook.com, what ends up happening is there is a lightweight machine learning model wherein we predict probability of click for me, which with each of these 100,000 ads. And then we filter out the top 1,000 ads which have the highest probability of click. And then for these top 1,000 ads, we use heavyweight machine learning model to do a second round of scoring. And the second round of scoring, it's you get a better estimate of the click-through rate. So this is the overview of the ad system. Any questions so far? Any questions? Okay. If not,
Hello, hello, sir.
yeah,
Uh, Sir,
go ahead.
for this ad pop-up, can you name any machine learning models that are used in this?
So we are using machine learning models to do the scoring, either be it the lightweight scoring or the heavyweight scoring. We use machine learning models to do that. So I'm going to be talking about some of those models in the subsequent slides. You can use in the past, before deep learning exploded, people used to use logistic regression. And after that, people started using gradient boosted decision trees. Now everyone pretty much is using deep neural nets. In the context of deep neural nets, there are several architectures that exist in this space. Uh, yeah. So yeah, I'm going to be talking about some of those in the subsequent slides.
Oh, thank you, sir. Thank you.
Okay, so now let's proceed to how we use machine learning to do this task of click-through rate prediction. CTR stands for click-through rate. So what this means is for every user ad pair, we want to predict the probability that the user will click on an ad. So let's say you have a user U, and then we show 5 ads to this user. And then we record the user's actions on these ads, meaning whether the user clicked on an ad or not. So if a user clicks on an ad, then you have a 1 corresponding to that ad. Otherwise, you have a 0. So the response variable for if you look at these 5 ads, the user U clicked on ad 3 and ad 5. So the response variable for ad 3 and ad 5 for this particular user U is 1. And for the other user ad pairs, it's 0. And then click-through rate is roughly of the order 1%. So what this essentially means is for every 100 impressions that were shown to the user, uh, only 1 resulted in a click, because users don't like clicking on ads. A lot of users, they just have ad block installed, or people don't like to, a lot of some, at least I would not say all, at least some users don't like clicking on ads. So because of which we see that click-through rates are, roughly of the order 1%. So what this means is for every 100 impressions, only 1 impression results in a click. What this essentially means is when you're training a machine learning model, you have a lot of negative examples. In other words, a lot of zeros, and then very few ones. So when you're training a machine learning model, what you typically do is you downsample the negatives. So instead of taking, let's say your training data comprises of 100 examples, instead of using, and in these 100 examples, let's say there is 1 click and the rest are all impressions, meaning the user did not click on them. So you have 99 negative examples and 1 positive example. So instead of using all these 99 negative examples for training, you downsample the negatives. What you do is you only use, let's say, 20% of the negatives. So you could train the model on 20 negative examples and 1 positive example. So when you're downsampling the negatives, you're changing the distribution of ones in the training data. So what you need to do is you need to scale the predicted probabilities. And then there is a nice formula that I listed here that you can use to scale the probabilities so that the probabilities reflect the original distribution of ones in the training data. So yeah. Okay, so when you're building a machine learning model comprises of features. So there are different types of features that are used while building a machine learning model in the context of ads. Some of the features are query features, context features, user features, ad features, advertiser features, and then you have interaction features between the above set of features. Okay, query features. So let's say you go to google.com and then you type in the query dining chairs. So what you can have is you can come up with an embedding for these queries, search queries. For example, you can use word2vec or Elmo or BERT to come up with an embedding for these queries. Another type of feature for the search query is the intent, inferring the intent from the query. So for example, based on the search query, you want to infer whether this query pertains to politics or electronics or clothing, things like that. So you want to infer intent. And then context. Context, as I said earlier, device. Is the user logging in from an iOS device or an Android device? Is it a desktop or a mobile device? What is the location? Is the user logging in from India, US? If it's India, where exactly is the user logging in from? Is it Bangalore, Hyderabad, things like that? Time of the day of the week, month. These are all contextual features. And then you have advertiser features, features such as domain. What is the advertiser domain? Let's say I'm in the space of selling electronic goods, then my domain is electronics. If I'm in the space of selling furniture, my domain is furniture. Uh, and then other features such as advertiser CTR. You have campaigns. Advertisers create campaigns to target audience. You have features pertaining to campaigns, and then campaigns have different objectives. What are features pertaining to that? And then you have ad related features. So ad comprises of textual information. There ads. There are also video ads. So you can come up with an embedding for that. Ads comprise of images. You can come up with an embedding for the images. You can use features such as click-through rate for the ad based on its history, recency of the ad, and then you can come up with an embedding for the ad ID itself. These are some of the ad features. User features, features such as age, gender, uh, time since login, how much time did the user spend on the website, user propensity, user interests is another feature, meaning different users have different propensities for different for example, a user could have a higher engagement with electronics and less engagement with fashion. Some users can have more engagement with fashion related content and less engagement rate with electronics. So that is user intent. User interest is one of the features that is used in a machine learning model. Or if you have search queries of a particular user, then you can use average embeddings of the past K search queries or average text embeddings of the last K click ads. These are some of the features that one can use, and these are user related features. Okay, now you have features, and then what are the models that you're going to use? So you, as I said, we can, in the past, people used to use gradient boosted trees, logistic regression. Now deep neural nets are more popular. Uh, within the realm of deep neural nets, nowadays people are using what is known as the two tower architecture uh, for a retrieval or the lightweight ranking. This is after the candidate generation. So after you trim down ads from 100 million to 100K ads, 100,000 ads, wherein you do a lightweight scoring. So in the lightweight scoring stage, you use the two tower architecture. Other architectures such as deep wide net are very popular for doing heavyweight ranking. Some of the architectures involving deep wide net are factorized deep FM, deep cross network, and then there are other architectures such as auto int that are quite popular in the industry. So what determines the architecture? So there are several things that determine what architecture to use. One of them is latency. And the other thing is the amount of training data that you have. Let's say your latency is very low. You want to show ads in a few milliseconds, and you can't afford to have an overly complex model. But let's say you can spend a couple of seconds if you have good latency leeway, then you can use an overly complex model to do the heavyweight scoring. And what loss function are we using? We use cross entropy loss to train this model, because this is a classification problem. You're trying to predict the probability of click, and the label comprised of zeros and ones. Ones are used to denote whether the user interacted with an ad or not. So these are some of the modeling choices that we could make. Okay, feature engineering, as we talked about, so we can use cross features. In addition to using user ad contextual features separately, we also use cross interaction features between these entities. We can use user ad context, user context ad. We can use all of these features in the model. And now let's say we built the model. How do we evaluate the model? So there are offline metrics as well as online metrics. So whenever you build a model, what you do is you first evaluate the model in an offline setting. And for that, you have metrics such as cross entropy loss, AUC, PRAUC, precision, recall, accuracy. These are some of the metrics that you can use. And you always evaluate the performance of a machine learning model on a test data set. And then once you deem, let's say you build a new model and then you evaluate its performance on a test data set using some of these metrics. And then you see that, oh, compared to the current model, the model that you built has better performance in terms of these offline metrics. And then at that point, you set up an online A/B test. And then when you set up an A/B test, you look at the metrics that matter for these social media companies. So as I said, if I'm Facebook.com, I care about, so I want to maximize revenue, but at the same time, I want to ensure that the users who are coming to my platform are happy, and the advertisers who are advertising on my platform are also happy. So you have metrics that are pertinent to Facebook. There are metrics that measure how happy the users are, and then there are also metrics to measure how satisfied the advertisers are. So in some sense, the optimization problem that Facebook or any other social media company is trying to solve is, I want to maximize my revenue subject to the constraint that the users are happy as well as the advertisers are happy. And then you have proxies to measure happiness of users and then also the happiness of advertisers. So I listed some of the metrics here. So click-through rate is one metric. We can measure downstream metrics such as conversions, cart ads, revenue, and then you can also look at other metrics like, okay, what is the session time? What are the average queries per session? What is the hide rate? Are the users hiding a lot of the content that I'm surfacing to them, which essentially means I'm showing irrelevant content to the users. It means users are unhappy. So you want the hide rate to be small. So on the other hand, you want click-through rate and conversion rate, revenue, cart ads to be more. So these are some of the metrics that we look at when we set up an A/B test, online A/B test. Okay, so what are some issues that we encounter while training? So cold start problem. So what I mean by cold start problem. So So let's say there is a new ad that is introduced into the system. There is a bias since machine learning models are trained on historical data. Machine learning models tend to favor existing ads. So if there is a new ad that is introduced into the system, if you were to look at the probability of click predictions for the new ads, the probability of click prediction tends to be low. So because of this reason, since the probability of click for this ad is low, get this ad will never get shown to the user. Since this does not get shown to the user, there is a negative feedback loop that happens, and then this ad never gets shown to the user. So this is called as a cold start problem, and to alleviate this problem, there are explore exploit approaches that are used. Thompson sampling is one of the approaches, and then there are other types of biases that exist in the training data. For example, in the context of search, let's say you search for something. Uh, Users tend to click ads that are in the top slots. Let's say you search for something, you search for dining chairs. I show you 10 ads. Users tend to click on first position ads that are shown in first position and second position, and tend to ignore ads that are shown in the latter position. So this is called as position bias. And inverse propensity scoring is used to tackle this problem. And then there are other issues that exist in the training data. For example, let's say in the context of YouTube, there are some users who use YouTube a lot, while some users not so much. When you're building a machine learning model for all users, if you have a lot of training examples from one particular user, so this results in a bias, and then that needs to be mitigated. The other thing is ad system is very dynamic, meaning a lot of ads get introduced into the system. Ads that are introduced today would not exist in the funnel 3 months from now. So if you have a machine learning model, its weights need to be updated on a regular basis. So you need to have a model that is amenable for online learning. So what this means is you need to do stochastic gradient descent every couple of days. In fact, we actually do it every few hours. So this is called as online learning. So you want a sophisticated system that allows for incremental learning. Okay, what are some of the other interesting problems in ads? So far we've been talking about how social media companies show relevant ads to users that come to its platform. Now, what do advertisers care about? Advertisers, as I said, they pay per click or they pay on an impression basis. But advertisers, what they really care about is not clicks or impressions that happen on websites such as Facebook or Pinterest. But what they really care about is conversions. So let's say if I'm advertising on Facebook, let's say I'm advertising, I sell shoes, I'm advertising shoes on Facebook or Pinterest. Some users are clicking on my ads, and then they're coming to my platform and not really making a purchase. So at the end of the day, I really don't care so much about the clicks or views that happen on Facebook, but what I really care about is the money that I'm making from these ads. So in other words, what I really care about is how many conversions that happened on my platform, how many users that I targeted on Facebook or Pinterest are actually converting and buying shoes on my platform. That's the metric that I care about. So for that, the problem that advertisers are solving is, when I'm advertising on this platform, I say, hey, this is the cost per click that I'm going to pay. So for that, I solve an optimization problem as an advertiser, and the optimization problem that I'm trying to solve is I want to maximize revenue subject to the constraint ROI, or revenue over spend, is greater than some target threshold. So this is the optimization problem that I'm trying to solve. So I want to maximize revenue subject to the constraint my ROI is greater than, let's say, 3 or 4 or whatever that number that is chosen by me. So based on this, you can actually solve this optimization problem. It has a closed form solution. And this essentially gives you a bid price. And the bid price is essentially revenue per click divided by target ROAS. Target ROAS is a hyperparameter, essentially. As I said, you can set it to 3 or 4. Based on that, you come up with the bid price. And revenue per click is essentially conversion rate multiplied by conversion value. And conversion rate is basically the number of conversions divided by the number of clicks. You have another machine learning model that essentially predicts the probability of conversion rate. So advertisers build a conversion model that essentially predicts, given a click, what is the probability that the user is going to convert. So advertisers build a machine learning model to do this. And then advertisers also build a model for predicting conversion value. So let's say there is a conversion. How much money will the advertisers make? So this is the conversion value. So using conversion value and conversion rate, you can compute revenue per click. And once you have revenue per click, you can compute the bid price. So the other interesting problem that advertisers solve is, now I'm an advertiser. There are several social media companies such as Pinterest, Google, Facebook, Twitter, Snap. And then I have a fixed budget, fixed marketing budget. Let's say I have $1,000. How do I optimally allocate spend on each of these platforms? So this is the problem that I'm trying to solve. So now let's say, to keep it simple, there is a typo here. Suppose there are 3 channels, C1, C2, and C3. These are 3 channels, and the spend on each of these 3 channels is S1, S2, and S3. Now, what I want is also assume that the profit as a function of spend are also known as profit spend curves. And we are furthermore assuming that the profit spend curves are concave in nature. And the profit spend curves for each of these 3 channels is denoted by P1 of S1, P2 of S2, P3 of S3. Then the optimization problem that the advertiser is solving is he wants to maximize his profit that he's getting from each of these channels. So on channel 1, you're spending S1. On channel 2, you're spending S2. On channel 3, you're spending S3. And then when you spend S1 on channel 1, you make a profit of P1 of S1. So it's a function. You have a function P1 of S1 that essentially gives you the profit as a function of spend. You have that for each of the channels. So you want to maximize the profit from each of the channels, subject to the constraint S1 plus S2 plus S3 equals B, because my total marketing budget is B, and I can spend S1, S2, and S3 on each of the channels, on each of the 3 channels. So the constraint here is the sum of the spends on all the channels has to be B. And furthermore, the spends are positive. Now, you can solve this optimization problem with the help of Lagrange multipliers and KKT conditions. If you use KKT conditions, we can find the spend values on the profit spend curves that satisfy this equation. The derivative of the profit with respect to the spend has to be the same for each of the 3 curves. So this is the solution. This is how advertisers compute spends on each of the channels.